Hello everybody, this is Carol speaking. Welcome back to our series of PolyWorks webinars. And today we are talking about how to use PolyWorks Modeler and PolyWorks Inspector together for reverse engineering. And let's welcome Todd Anderson as he is our presenter today. Todd is a member of the technical support group. And let me remind you that if you have any questions during the webinar, please use the questions panel. So yes, we are keeping the same format. And I will be monitoring the questions throughout the webinar. We will have a short Q&A session at the end. And if we don't have time to answer all of the questions, we will get back to you by email. And yes, we are recording this webinar, so it will be available for later viewing. Todd, it's all yours.
Great, thank you, Carol. So in today's webinar, we're going to look at the new transfer objects command that was added in PolyWorks 2018. We're going to see how it benefits us in several reverse engineering tasks within this webinar. The overall goal today is to show how easy this command is to use and why we believe it will erase the thought that we have that there's a major distinction between modules. It's going to be as simple as a single click. So let's get a look at our first project and see how this is going to work. So typically when we're doing a reverse engineering project, we start off with within Inspector, and we're going to go through and scan a particular part that might be that we're looking at or working on. From that, we would have a polygonal mesh that has been created. So inside we have our mesh. We may need to go through and probe some features that are existing through here. So you can see on the model that I've gone through and probed two of the circles that are there. And after the mesh is created, a couple other features can be fitted to the particular polygonal mesh to allow us to create a local coordinate system, something that we can use that makes sense to us when we're going to do reverse engineering and or we're sending our reverse engineering model down the line to another software. So up till now, it's in order for us to continue with this, one of the things that we would have to do is we would save the project and somehow export out the polygonal mesh. That was a lot of clicks that took us to get there. However, with the new function, it's as simple as just right-clicking on the scan data, and you'll see that the new command is there, which is transfer to modeler. Now, when I click this as it goes through, what will happen is we will have a brand new modeler project open up, and the scan is basically transferred over. We don't have to hunt and peck. We don't have to go through Explorer or the Workspace Manager to find it. It's just as simple as, again, one single click. This would allow us to go through and start doing our reverse engineering. So a typical reverse engineering workflow is when we bring this model in, we may need to go through and work on some of the shapes for this. So I'll tear off the toolbar so it's quick and easy to access. We may start off by just running a smooth over the whole object, and then simply going through and running a hole fill to fill in all of the holes that are there for us. Now, we had some feature holes that were inside of here, and I had probed those. So during the hole fill, this might be a situation where I don't want to guess with any of this. I would want to use the function where I could bring those curves in and punch a hole either in the polygonal mesh or go back and punch that hole in, say, a NURBS model. So this would allow me to go through and actually within our workflow, we typically say, all right, when we're going through and doing this, maybe what we want to do is get rid of our mesh in those regions and just run the reconstruct on that. That would allow us to go through and fill in those holes for us. Sometimes the geometry gets a little bit crazy, and especially when we're doing a volume selection, certain things tend to get in the way, and so we may actually have to come back through and erase this and get everything set up. Everything looks good. We can run our reconstruct mesh and our holes disappear. So this sets us up for us going through and ready to go through and start laying our curves in to create our NURBS model. Now, one of the things I see that happens a lot, and this is a tip that you might not be aware of if you don't use Modeler as much as you used to, or tend not to use it as much, is we forget to turn on down here at the bottom the dynamic NURB patch creation. By default, it's turned off. So one of the things is always, it's helpful to turn that on when you go to start laying in your curves. As we go through, a typical process is we would want to go through and put our feature curves in first. So it's as simple as just coming through and placing in fillet curves as they are on the model. And or if we had an open boundary, we could actually go through and create those curves as well. So once we have our feature curves created, it can be simple just coming through and saying, okay, I've got some good feature curves inside of here. It's hard to tell where the major features are through here, but we can actually go through and use the standard curve creation, say maybe the anchor line, when we're in a view where we're looking from the side, to say, you know what, it looks like we're going to break it up about here, maybe about right here. And if I want, it looks like it's getting a little flat at the top, I could come through and pop one in just a little bit lower. So this would give me some extra areas that I could place these curves in. And the nice thing is all I have to do is 2 clicks on each side. To connect my feature curves, it's as simple as just dropping in, say, a vertical in this view, and then going through and rotating around maybe 90 degrees, pop in another vertical where I'm connecting my feature curves, and in the end, I would have surfaces generated throughout the model. So something like this can be done really quickly and really easily. As soon as we have everything in, it's just a matter of fitting our NURB surfaces to the model and seeing what our results are. So for this, it might take 5 or 6 seconds for it to fit, but in the end, we should have a nice set of surfaces that are there. Typically within the reverse flow, when we're looking at this, we'll come back through and look to see how well our surfaces are fitting. So we might look at a fitting error just to see, okay, when I laid these curves out through here, what am I looking at as far as the error goes? So in this case, it's minus 0.16 to 0.135 as far as just laying these in. However, I do have a nice set of smooth surfaces through there, and this was done very quickly. For me to go through and to reduce this, I could either go through and work with the fitting parameters on each one of the patches, or I could simply come in and add more curves and try to reduce my error. So the typical workflow that we're working with inside of here is still valid in the fact that we would go through and look at everything that we're dealing with and fitting within the patches and seeing our errors. One of the things that I'm missing from this, though, is remember the holes that we had inside of here, those circles that we were talked about possibly pulling in from inspect. Well, those are still available for me. And one of the things that I can do is I can actually go back to the inspector project. And initially, the only thing I had done before was I had just said, let's transfer the polygonal mesh over. However, since this is an objects transfer command, I can actually go to different objects within the tree, and I can select several of them as well as different types of objects. And with a right click, the transfer to PolyWorks modeler is there. When I've done this the first time, the link was established to that particular modeler project. So as soon as I click this, it takes me longer to explain what happens than it does for the objects to transfer over. So here we can see that I've actually brought these circles in. So if I hide my NURBS patches and we look at the 2 circles, they're there. Now what I'd like to do is actually take these NURBS patches and convert them to become a NURBS model, which would allow me to go through and cut. So simply going through with the typical workflow, we can convert everything over, and then we can take those 2 circles and we can actually punch a hole in. So if we get our values up, always look to make sure you have a preview to make sure you're cutting all the way through, apply, And now we have a nice model that has been created, and it's a NURBS model with the holes punched in for us, and it's available for us to export everything out. So with this, what I want to do is actually save this project and call it doorknob 2. And it helps for me to spell things correctly. So once I've saved this project, the transfer of objects isn't one way from PolyWorks Inspector to Modeler. It actually goes both ways. So if I were to come to this NURBS model, I can actually export or transfer a copy of this to the Inspector project. Again, it's associated and linked back to each other, and this gives me a set where I can pop the NURBS model in, and it's imported in as a reference. So how beneficial is this for me? Well, we had gone through, when we were working in the process, we looked at the fitting errors that were done on the individual surfaces. However, in Inspect, we actually have a higher end tool that we can use to go through and look at the fitting errors again, and we actually have a little bit more control. And that's typically just a color map for us to go through and do data to reference. You can see that we have a color map that's been brought in. And when it's brought in, we see that we've got points that are shown up as in the texture for the model. One of the things that's also available for us is when we're going through and we're working on this and looking at, say, the color maps, we have the ability to run a textured model through here. So if I actually had that set to texture and then bring this in, we have a very nice smooth color map where we're showing inside of there. I have the ability to go through and make changes to how we're displaying the model. So just like the fitting error that was in Modeler, this fitting error actually will allow me to go through and add more tools in, such as I can actually come through and pop annotations in. I could go through and change the color scale or the range that's there. I can even set up my own customized version of this. The biggest thing is I can report this out. So this is one of the things that we haven't seen before, is going through and documenting our reverse engineering process. So not only did we just create a model, we've actually easily been able to transfer it back into Inspector, where we have what I'm calling a higher end tool as far as measurement goes, that is available for full documentation. So if there's any questions on your reverse engineering, you can have that's associated back with your model. So the transfer back and forth is very easy, and it's a simple one click. So that's one of the things that you might want to start working with and looking at using the benefits between each of the modules. So with this, what I want to do is I actually want to go through and show you a second example of reverse engineering using Inspector and Modeler. So again, we have a typical scan of a part. Now, in some cases, I know a lot of you have seen this before, is when you're scanning, say, a pocket region. So if I kind of rotate this around, you can see that when we've scanned inside of there, for some strange reason, we have a hole right here at the bottom corner. It can be a matter of there's no material there. It's actually very shiny, where we have some grease or something that's giving us no feedback. Or it could be simply that the sensor that you're using to scan is too big and you just can't quite get the angle to get down inside. Well, this is typical for something that is a pocket, but also things that have details that may be protrusion up, fins, small, tiny fixtures and or fittings, so to speak, like screws, nuts, and bolts. These, if are needed, we would want to go through and be able to scan as much as we can. And then when we do the reverse engineering, what we want to do is as little work as possible. Now, for us to go through and send this over and to repair this inside of Modeler, this will probably take a lot of work. I would probably have to do some center line tracking going through and filling polygons back in, create sharp edges, and then maybe I should have the ability to use, say, the rolling ball fillet to match these fillets back in. It is very possible to go through and reconstruct that corner, but it's going to take a little bit of work. Well, here's one of the tips that you can use to kind of get your workflow a little bit faster, and that's actually using Inspector with the new transfer. Things can go a whole lot faster with that. So in Inspector, one of the things that we can actually do is we actually have the command to use a best fit data to data. And so one of the things that you may have is, and in this particular case, I have a corner in this bottom pocket that actually resembles this same area right here. It would be really nice if I could somehow take that data and match it up over there and kind of blend that in. Well, here's a process that we can go through and do that. So in this case, what I'm going to do is I'm just going to go through and select, say, this corner region. Make sure I get it just enough on the outside with each one of these. And with those elements selected, what I can do is I could come into that particular object and say split and copy the elements. What happens is we get a copy of just those particular elements and a new object is created in the tree. Now, both of these objects, since it was just a copy, still hold the alignment group, the first alignment group. So one of the things we would need to do best fit data to data is to actually break this apart. So what I'm going to need to do is come in and say edit, and I want to unlink the device position for the second one. And I would also want to unlink the alignment group and have the second scan have its own alignment group inside of there. So once that's available for me, now I can actually come through and use best fit data to data. Pre-align using point pairs. This is a typical inspection or workflow. Everybody's used to doing this and working with it. We try to make both screens look the same before we go through and pick. And then it's as simple as just going through and adding in your point pairs. Now, if you've heard some of my tips in the past, one of the things I always tell everybody to do when we're doing this is when you're placing your pick points, always try to form a triangle as far as the data goes between each one of them. And this will allow us to get a better fit when we're working inside of there. So you can see that quickly, it's as if the hole was not existing and the fit is perfectly inside of there. Now, with this all set up, we can simply go through and transfer this over to Modeler. So if I select both of these, I can transfer. Now, one of the things that will happen is when we're going through and doing a transfer, PolyWorks, remember, it always keeps up with everything that we're doing. If I haven't saved this project yet, it will remind me that I need to save that. So again, we're keeping up with everything that's going through, and a new modeler is open. You can see that when I open this up and we zoom in and look, it's as if this is one nice single mesh that's inside. We can simply just come through and select both objects and merge them together. So I merge polygonal models. The first one has the missing corner. I want this one to merge into it. I only want them to merge at the boundaries and delete the second one after it's done. And something as simple as this, I now have one polygonal mesh. And if I go to wireframe and we zoom in down here at the very bottom, you can see that the blending of that corner is pretty nice inside of there. And I don't have like two layers of triangles. It's gone through and replaced that corner with the other corner that I've popped in from the model. So the transfer back and forth, again, is so simple and so easy. It's a one click. And I'm hoping today that after you guys have seen both of these demonstrations that you won't be so nervous to transferring objects back and forth between projects. So with this, I would like to go ahead and take questions if we have any.
Yes, Todd, we do have some questions that are coming in. So the very first one, can I transfer the mesh to an existing Modeler project, or does it always create a new one?
Oh, Okay, so in this case, what we have is, when I said, let me think about that one for a second. So we're saying that or my statement earlier where I said PolyWorks keeps up with everything, when we're transferring things back and forth, this is always done at the project level. And so controls for that would actually be under the project within our options page. So when we come back and if we were to look at something like the project, when we go through and look on the modeler side, when it transfers through, this is the destination for the particular project that's there. If I need to send this back to inspect, I can actually send it to either any projects that are already saved or create a new one. Now, if I look at that same thing under inspect, so if I go back to the doorknob and we go to tools, options, same thing holds true for the projects inside of here. Do we want to send it to create a new one? Or if we have one that's already opened or an existing one, can we send it to there? You can go through and actually set that up so it always goes to a particular project or it only goes to an open project that's there. However, we give you the full ability. The biggest thing is we always have way too much that we're on our plate, and I always say don't outthink the software. We're keeping up with everything, and this is pretty much where that's going to be kept and controlled.
Okay, and we'll squeeze one more question in here. Regarding the first example that you did, you mentioned cross-sections and transferred one over, I believe. So how would we benefit from cross-sections in Modeler?
Okay, thank you for bringing that back up. I went a little bit fast, it looks like. Yeah, I did bring a cross-section over. So if we go back to that modeling project, it was this one. So why would I bring the cross-section over and not use it? Well, for this example, what I wanted to show was surfacing and doing the patches and punching the holes in. But we also, remember, we have the ability to go through and do reverse engineering using sketches that we can that we can send to CAD models. One of the things that's available for us, even though we have a polygonal mesh inside of here, and when we were to go through and say to start a sketch, we always have the base planes that are there, but we can use cross sections. And the particular cross section that I brought over, instead of us creating one, I can import them in from CAD. So maybe in this particular sense, if I rotate this model around, one of the abilities in Inspector is we can actually do radial cross sections that would go around the model. And maybe that's something we would want to use for sketching. So having a cross section brought in, it's as simple for us, we already have the outline, we could go through and just start to put in our sketch entities and just continue on modeling this based off of the cross-section outline that's brought in versus us creating a new one or using the base planes. So again, you pick which tool is going to be the fastest to get what you need and to get out of Modeler as fast as possible. Thanks for reminding me I brought that one over.
We cannot get past our users, Todd.
No.
They're quite following you. And this is all the time that we have for the questions, but we do have some extra questions that are coming in, so we'll get back to you by email. And yes, this webinar has been recorded. It will be available on the Innovmetric software website. Navigate to the support section. It will also be available on the Innovmetric software channel on YouTube. And our next webinar is scheduled for October 11th, and we'll talk about how to leverage the use of scripts in your inspection sequences. So definitely some interesting topics coming up. Thank you for joining us this morning, and we'll see you next time. Bye-bye, everybody.